Okay, we're doing some more thermodynamics. So, today we're going to be using Hess's law. And so I have my detective hat on because whenever you're doing Hess's law, you're playing a detective. You're piecing together all the clues to figure out the final thing that you're looking for. It also doubles as an Indiana Jones hat because, science is always an adventure. All right, so we have our starting reaction here. We're trying to find the delta G naught and the K value for this reaction. Okay, so we're given a whole bunch of different reactions. I'll put those like right here to see if we can build our reaction and see if we can figure out what the delta G naught for this reaction is. Okay, so the first thing I'm going to look at is that top reaction because I see it has a carbon, and we're always looking at our target equation to see if we can build it. So I'm seeing that we have a carbon in our first equation, so I'm going to try and use that one first. So it's on the right side, it's on our reactant side, so I'm going to write that down. So we got our C plus some O2, which doesn't show up in our target, so we'll have to get rid of that later. But for right now, it's fine. Going to CO2, which is also not in our final. That's okay. We can work on that. I'm going to make a list of the delta G's over here, delta G naught for our reaction. And in this case, it is negative 12.2 kilojoules per mole. Okay, so we haven't had to mess with anything here. We're just going to write that one out because our carbon's in the right place. Let's look at our next equation. So our next equation has carbon monoxide in it, and oxygen, and CO2. But it has too much carbon monoxide. It has 2 moles of carbon monoxide, where we only need 1 in our target here. And it's on the wrong side. It's on a reactant side instead of a product side. So what are we going to have to do in order to get that reaction looking like this reaction? That's right, we're going to have to flip it, and we're going to have to divide it by 2, or half it. So I'm going to put it out over here to the side, just to say what we've done to this thing. I'm going to put a little arrows in a circle to show that we flipped it, and a little half to show that we've divided it in half. So then, after that, we get CO2 going to CO plus half of an O2. Okay? And so whatever we do to one of our things, whatever we do to one side of our equation, we have to do the other. And since our delta G is part of our equation, we have to do the same thing that we did to the equation to our delta G value. So originally this is plus 5.8 kilojoules per mole, but this is going to end up being negative because we flipped it. We got to flip the sign. And since we divided it by 2, we got to divide this number by 2. So this ends up going to be 5.8 divided by 2. Okay, so I'm just going to leave that there, and we'll do all the math when we do it together. All right, so now we're still missing the water, and we're missing the H2. Luckily, our final equation gives us those 2 things, but again, they're on the wrong sides. You see, we have 2 H2 gas plus O2 gas, giving us 2 waters. But our water is on a product side in our new equation, whereas a reactant in our target. So we're going to have to flip it again. So we're going to do a little flippy sign again. Flip, flip. Okay? And we have too many, right? We only have H2 up here and 1 water over here. So we have too many in our other equation. So we're going to divide it in half again. So that will leave us with a water, 1 water, H2O, going to an H2 plus half of an O2. And then same thing, whatever we do to one side of our equation, we have to do to the other. Same as algebra rules. And since our delta G of our reaction is part of this reaction, we got to do the same thing. So since it's already a positive 14.3, this will be a negative 14.3. Put our units in here, kilojoules per mole. Same thing here, kilojoules per mole. And we're going to divide it by 2. Okay? So now, we've used all of our reactions. Let's see if we've made our target reaction. So I'm going to put a little line down here at the bottom, and let's see what our net reaction is. Okay? So let's go through and let's do my favorite thing, in all of science. Let's cancel things out. Feels like we're cheating, right? So if we ever have something on the left side of our arrow and the right side of our arrow, we can cancel it out. So let's see, we have one CO2 here, cancel. Another CO2 here, cancel. Okay, so that works so far. We have a whole oxygen here, and then two halves of oxygen here, so we can cancel that, and cancel that. Leaving us with carbon plus water going to carbon monoxide plus H2. Our target equation. Yes, we did it. Excellent. But now, what is the number that we get from our delta G? Well, all we have to do is we have to add up straight down what we got. So it'll be negative 12.2 plus negative 5.8 divided by 2 plus negative 14.3 divided by 2, which, if you plug into your handy-dandy calculator, I got 22.25 kilojoules. Okay? But are we done? Let's go back up to the top. It says find the delta G naught of our reaction and the K. Okay, so we have a little bit more we have to do. So how do we find the K value given what we just did? That's right, we need another equation. So I'm going to leave this down here. I'm going to erase this. Hope everybody's got it. If not, rewind. You guys have the power of time control. And y'all can just rewind and write down what we had. Okay, so what formula do we need in order to get our K value? Well, what do we have? We have a delta G for this, right? We have a temperature, 298 Kelvin. So what's something that we could use that could give us our K value? That's right. I'm going to use a different color here. We're going to use red. So red is a fun color. All right, so our formula that we can use is delta G is equal to negative RT ln of K. All right, so let's use this formula. Let's plug in what we got and see what we end up with. Remember, what are the units of R? Remember, it's 8.314. What are the units? That's right, joules over mole Kelvin. All right, and what are our temperature units in? So everything cancels out. Kelvin. Right. All right, so if this is in joules, in order to actually use it with our delta G, we got to make sure that this is also in joules. So let's make sure that we have that before we plug into our calculator. So since it's negative 22.25, we're going to say that this is negative 22,000. 250. Okay? Is equal to, I'm going to erase this, negative 8.3, and this is in joules. Make sure we have all our units. 8.314 joules per mole Kelvin times our temperature, 298, also Kelvin, times the natural log ln of K. Running out of room. All right, so now we have that. Let's find our K. So if we divide both sides by our R and our T, we'll end up with a negative RT over here, right? And that'll cancel this. And we're left with just this is equal to ln of K. So how do we unnatural logify something, the technical term? Unnatural logify. That's right. We take it to the E. So if we E this, that will cancel this, leaving us with just K. And if we E this, we should end up with K equaling, I got 7,947. Okay? So now we have found both the delta G naught of our equation and the K value for our equation. I think we're done here. Have fun, guys.